Alright, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your chemistry teacher for this session. So what we're doing in this journey and in this process is we're going through some commonly and frequently asked problems in chemistry and mathematics, specifically in the secondary school level, as well as also in the university and college level. And what I'm doing for this next 1 hour is I'm going to have about 10 questions for us, ranging from anywhere between grade 9 all the way to grade 12 chemistry problems. So if you're tuning in from the US, this is probably looking at junior chemistry, junior level chemistry and senior level chemistry. And what we're doing is I'm just verifying these solutions for you. So I'm going to teach you the concepts through the problems, and we'll be able to solve these problems together. So again, my name is Joey. I'm currently a secondary school teacher in the Ontario board, and I'm currently a teacher for OneClass. And my subjects of interest are chemistry and mathematics. So let's get started on today's problems. We're going to have about 10 problems for us today within the hour, and we'll see how far we get today. All right, first question is asking us, it says write the molecular equation, complete ionic equation, and net ionic equation for the following reactions. So they gave me a list of like 16 of them, so I'll probably do like 2 just to teach you the concepts, and then I'll look at some of the problems here and verify the solution. So let's do number 1 here, and this is like 16 problems, so I'm definitely not going to go through all of these problems with us because it's going to take way too long. So we have our first problem here. It says copper 2 sulfate and sodium carbonate, right? So let's write out the molecular equation for that. So we have copper sulfate. So we have some Cu, and then we have SO4 2 minus, and this is 2 plus and 2 minus here. So it's going to be just simply CuSO4. So we have CuSO4 plus sodium carbonate. So it's Na2CO3. Because again, the CO3 has a 2 minus charge and the Na has a 1 plus charge. And this is going to give us some type of molecular compound. And what we need to know is we want to figure out which one's insoluble in water. So we have copper sulfate and we have sodium carbonate here. So let's look at our double. It's going to be a double displacement reaction. So we're going to get copper, which means we're going to get copper carbonate plus sodium sulfate. So this would be Na2SO4. And what we can do is we can look at our solubility table and figure out, okay, which guy is going to be the insoluble product. And we can look at copper. We can look at copper carbonate here. It says insoluble except group 1 in ammonium. So therefore, this guy is going to stay in the solid form, and this one would be aqueous, and these guys would be in solution as well. So what I want is, again, I want to figure out my net ionic equation for this reaction. So let me just take out the phases actually, because we just care about this guy here, which is a solid one. So let me write that down. So this guy is solid. So what I want to do is I want to break these back into its ions, right? So I'm going to have Cu2 plus, and they're all in solution, right? So Cu2 plus aqueous plus I have SO4 2 minus. This will also be aqueous. Plus I have Na plus aqueous plus CO3 2 minus, which is aqueous, and I'm going to get simply copper carbonate here because this is not in solution, right? This is going to be our precipitate here. So this is CuCO3S plus, again, Na plus SO4 2 minus here. Okay, so what we can do now is we can actually start to cancel some stuff out, right? I see I have sulfate on this side and sulfate on this side, and I have sodium on this side and sodium on this side. So therefore, we can write our net ionic equation as Cu2 plus aqueous plus CO3 2 minus aqueous is going to give us CuCO3. And this is going to be our net ionic equation for this problem here. So this is going to be number 1, and let me just check the answer and see if this one is right as well. And we have copper sulfate and sodium carbonate yields copper carbonate and sodium sulfate, which is good. We have the ionic equation, which is Cu2 plus, SO4 2 minus, 2 Na plus, and CO3 2 minus. There is supposed to be a 2 here. So sorry, because there's a 2 in the coefficient here, which means there should be a 2 here as well. But either way, it doesn't really matter because both of them do cancel out at the end. And the net ionic equation, we get copper 2 plus carbonate, the carbonate ion, which is CO3 2 minus, which will give us CuCO3. So this is the correct answer for number 1. So this solution is correct. So let's do one more problem. with this. So let me just erase these guys here. And we will do one more of these problems just to reinforce the concept here. I'm just going to clear the page actually. And we'll do, I guess this is 1B. So this is copper sulfate and barium chloride. So we know that this is copper sulfate from the previous question. We have barium chloride, which is BaCl2, because Ba has a charge of 2 plus and Cl has a charge of 1 minus here. So this is BaCl2. It's going to yield, I'm going to get copper chloride here. So this is CuCl2 plus I get barium sulfate, BaSO4. So again, we want to look at the solubility charts for these guys first. So let's look at our solubility. So let's look at our solubility for copper chloride. Again, this is soluble except for Ag, silver, mercury, and lead. So therefore, copper chloride is soluble. We look at barium sulfate. So it's soluble. So sulfate soluble except for barium sulfate. So barium sulfate is going to be my precipitate in this reaction. So I'm going to put a little S here. And then now we can break this down into our ions, right? So I'm going to have Cu2 plus. I'm not going to write the aqueous states here because we're going to imply that all of these guys are aqueous. And I'm going to have 2 Cl minuses, sorry, in this case here. And then this is going to yield Cu2 plus 2 Cl minus plus BaSO4. And we know that that's going to be a solid because that's going to be insoluble. And now what we can do is we can cross some stuff out. We can cross out this copper. Copper appears in the reactants and products. Chlorine also appears in the products and the reactants. So what we can do is we can write our net ionic equation as, we write the metal first. So this is Ba2 plus SO4 2 minus is going to yield barium sulfate. And this here is our answer for this problem. So Ba2 plus SO4 2 minus gives us barium sulfate. So BaSO4 in solid form. Let's look at our answer here. So we have copper sulfate and barium chloride yields barium sulfate and copper chloride, which is good. Our net ion equation, our ion equation is copper 2 plus, SO4 2 minus, barium 2 plus, and 2 Cl minus yields barium. This is supposed to be BaSO4 actually, so they misplaced this ionic guy here. It's BaSO4 and copper 2 plus and 2 minus, which is good. And the net ionic is Ba2 plus, which is barium, and sulfate plus yields barium sulfate. So this solution is correct, except this is supposed to be SO4 here. I'm not going to check the other guys here. I'm going to assume that that's going to be correct, but that's kind of how you do the net ion equation. Again, you're figuring out which one's soluble and which one's insoluble from the solubility table. We then break them down into ions, and we can then see which guys we can cancel out, and what's ever left over makes up the net ionic equation. So I'm going to say this solution is correct.